In this lesson on classroom mathematics, we are busy with chapter 12, geometry of 2D shapes, and today we'll look at similarity. Now, for an overview of what we'll be doing in this video, first we're going to look at equilateral and proportional. Then we're going to look at how to prove similarity and determine sizes. Now first, before we get started, let's just see what is similarity. Now, similarity means that two shapes or two objects have exactly the same shape, but they have different sizes. So let's just look at an example. This is just a random shape, but their shapes are identical, but their sizes are different. And since we're working with triangles, there's two examples, or an example of two triangles that are similar. Now, equiangular and proportional. So if we're given that two triangles are similar, if they tell us that these two triangles are similar, then there's two things that we know about the triangles. The first thing we know is that it's equiangular. In other words, we know that all pairs of corresponding angles are equal. So if we look at these two triangles, we can see that angle A is equal to angle P, and also angle B is equal to angle R, and then angle C is equal to angle Q. So that's the one thing we know about two triangles that are similar. Then the second thing we know is that all pairs of corresponding sides are in proportion. What that means is, if I take AB over, now see A to B, so A is equal to P and B is equal to R, so that would be P over R, and that would be equal to then BC, so from B to C is the same as from R to Q, so BC over RQ is equal to, and then finally AC over, and its proportional side from A to C is the same as from P to Q. So this tells us that AB over PR is equal to BC over RQ is equal to AC over PQ. So that just means it's in proportion. This side over its corresponding side equal to this side over its corresponding side. Right, so just to note, the labeling order of the triangle should indicate which corresponding angles are equal. Then we can easily see which corresponding sides are in proportion. So what this means is, if we've written that triangle ABC is similar, so when we write similar, we have three strokes downwards. This means similar to triangle, and then when we name the second triangle, we name so this A was equal to P, we name it in the same order as their equal angles. B was equal to R, and then C was equal to Q. So now we know that A is equal to P, B, R, C equal to Q, and so forth. Now this says that then it's easy to see which sides are in proportion. So what you can do is you can draw this little face where we know then that AB is in proportion to PR and BC to RQ. So that then we can easily read off these two. If this is in the right order, we can easily read off this that AB over PR is equal to BC over RQ, and so on. Alright, then the second note, if two pairs of angles of two triangles are equal, then the third pair of angles must also be equal, because the sum of the angles of a triangle is 180. So this basically says, let's say that we're only given B and C is equal. We haven't been given anything about A and P. If we are given two of the three angles are equal, then we can no, then we know that the third one will also be equal. And we always state the reason third angle of a triangle. Right, so in the previous cases, it was told us that the triangles are similar. That was a given. Then we could deduce that they will be equiangular and their sides will be in proportion. Now, converse is just going backwards. Let's say we're only given that the angles are equiangular, then we know that they are similar. So in this case, we are given that all the angles are equal. Then we can deduce that they will be similar. In the previous case, we were told that they are similar, then we could deduce that the angles are equal. And also, if the corresponding sides of the two triangles are in the same proportion, then they are also similar. Alright, so that was equiangular and proportional. Now, we move on to proving similarity and then determining sides. So for example 1, we have to determine the length of the unknown sides, and we are given that triangle ABC is similar to triangle PQR. Now remember, if we are given that they are similar, we can know that their sides are in proportion. So let's say, and remember this in this order, we know that AB over PQ, so AB over PQ is equal to BC over QR, BC over QR is equal to AC over PR, AC over PR. Alright, now that we've established our proportionalities, now we can basically just substitute in our known values. We know AB is 30, and then we've got PQ is 60, then we're given BC is Y, and QR is 80. Then for AC is 25, and PR is X. Alright, so as you can see, to find X and Y, we can let's first start with finding X. So if we only use this one and this one, because see, with this one, both are known. So if I just equal 30 over 60 is equal to 25 over X, then I can solve for X. So in solving for X, let's just first simplify this. This is the same as 1 over 2 equals to 25 over X. So use the cross multiplication method where we take X up and we take 2 up, then X will be equal to 50. Alright, and then for Y, I'm going to say that Y over 80 is equal to 30 over 60. So once again, Y over 80 is equal to 1 over 2. So if I take the 80 up, then I'm left with, so this becomes, let me just work on this side. So this becomes Y equal to 80 over 2, which is equal to 40. So Y is equal to 40. Then for example 2, now in this case we need to prove that triangle ABC is similar to triangle ADE, and we need to determine the value of X. Alright, now this is important to know, but it's really a simple procedure, and it always follows the same procedure in proving two triangles similar. The first thing we do is you state the triangles you work in. So you're going to say the heading in triangle ABC and triangle ADE. Right, so that's your introduction. We're working with these two. Then we need to give 3 reasons. We always need 3 reasons, 3 things that are equal. In our case, it's always with similarity, it's always 3 angles. When we do congruency, it can be a side or angle, but we'll get to that in the next lesson. For now, in similarity, you always prove this 3 angles equal to each other. So the first thing is we have ABC, which is the big triangle. And then we have ADE, which is the smaller triangle. So the first thing I can see is that this triangle A is equal to itself. So it belongs to both of the triangles. So I'm going to say that angle A is equal to angle A. And the reason is because it's common. It's common to both of the triangles. Right, the next thing is I can see that these two lines are parallel. That means that these two angles here are corresponding angles. So then I can state, okay, angle B is equal to angle D1. And my reason for that is corresponding angles. And then I have to state that DE is parallel to BC. All right. And then finally, I can say that E1 is equal to C and give my reason. There's two reasons you can give. The first reason, you can say that it's the third angle of a triangle, or you can state that these two angles are also corresponding angles. I like to do that. So I'm going to say that angle C is equal to angle E1. My reason is also going to be corresponding angles, and once again DE is parallel to BC, although you could have said here the reason third angle of a triangle. Alright, now that you've stated three things that are equal and given them their reasons, you can end off by saying, therefore, triangle ABC is similar to triangle ADE. And then you have to give your reason, and with similarity it's always angle, 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 because we've said three angles are equal. Alright, then for B, determine the value of x. So that we've done in the previous example as well. Since we now know that these two triangles are similar, we can use the proportion, and we have established that these are in the right order, ABC, ADE, yes. So therefore, AB over BC, AB over AD is equal to BC over DE, and AC is equal to AC over AE. Now the X is the AE side. What else are we given? We're actually given all the other sides, so we can choose which ones we want to use. Let's just make sure we have AE in our equation. So let's start with AE over, so AE is proportional to AC. Then I can use any other two. So let's say these two seem better to use, because we've got this whole AC is going to complicate matters, because then we're going to have an x plus 3 in our equation, so that's going to complicate our equation. So let's use then DE equals to DE over BC. Okay, so let's just substitute on our values. So AE was x over AC is, AC is going to be the x plus 3. Okay, so that's going to be x plus 3 equal to DE is 8 over 12. All right, so once again, we just have one term over here, one term over here, so we can apply cross multiplication. So I take this denominator up and 12 up, so this gives me 12x equal to 8, and then x plus 3 in brackets. Now this is just a simple equation to solve, so 12x equals to 8x plus 24. Take the 8x over, 12x minus 8x equals to 24. Then 12 minus 8 gives me 4. 4x equals to 24. And then divide both sides by 4 gives you x equal to 6. Right, so that was how to prove similarity and then how to determine sides. You should now be able to do exercises 12.5 and 12.6.